Hello, welcome to the first unofficial edition of the Enterprise Rack Challenge podcast with IBM. We wanted to answer a lot of questions that have been asked about the winning solutions, about the winning architectures, how things worked out, and how things worked out, especially with the IBM watsonx. And today with me is Daniel Stanek from IBM. He was the person that helped us to run the watsonx track, provided access and the tokens and all the support. And Ilia Riz, did I pronounce your name correctly?
Yeah.
Ilia Riz, he was the official winner of multiple tracks. And today we want to figure out and share with the community how did Ilia do that. So actually, Ilia, how did you win?
I think the main key to get a first place set, it is to invest a lot of time. This is the main key, and I believe systematic approach, because I was highly invested in like deep domain understanding. I dig really deep. I created like validation dataset when Renat make new question generator available. In that same day, I generated 100 questions. I ran my half-baked system and I manually validated all these answers, and I analyze them. I look the places where my LM system has a lot of mistakes. I try to figure them out. I write actually like the financial reports itself. I opened the relevant page and I read in what is the reason. Sometimes it was obvious. For example, one of the errors that models did a lot of times, it is with values of metrics, for example, revenue or something in financial reports. It is always written like in thousands or in millions, and LM often just put it out like number and put it in answer. And I suppose then, or not, when you validated all the answers, I think it was the often error of different submits that model errored on 3 zeros or 6 zeros. Am I right?
Actually, so I didn't validate the answers manually. What I've done is I looked at all the questions during the final run, and I was able to cheat because I had already all the submissions. And I still had to manually proofread them so that we have more or less stable answer set. But for each of the questions, I could already see the cloud, like what were the distribution of the answers between different teams, what pages did they refer. And then I had mostly to look through the pages that already were highly likely to contain the answers and just validate for them. And given that, it took me pretty much a week just to go manually through the hundreds of pages, and especially the fun report with the 1,000 pages. And actually, this brings me a question, Leah. So you said that you've done this work using the test data set before the competition started. So how much time did you have to invest manually reading the PDF reports to create the evaluation data set?
Oh, a lot. I think I remember when we made a dry run a couple of weeks before the competition. It was only 30 questions, and I read them thoroughly. I wanted like to help you with validation process, and I researched each question not only in the reports. I tried to prove it from like web results and etc. And I written like argumentation for each answer, and there was a problem, for example, that one question could have 2 different answers, and both answers had like valid argumentation. And I wrote all this down. And it took me these 30 questions, for example, took me around, I believe, 9 hours or something like that.
Oh.
Yep. And writing this argumentation helps a lot to understand like pitfalls of different questions. For example, there was a type of question about leadership position changes in company, and it's like a philosophical question. If new appointment, like for example, in merging company, there is a new board member. If that is a changed leadership position or not. I believe both answers valid, and you need to ask your customer, Renat, for example, in this case, what he needs to get as an answer in this case. So this helps a lot. You need to understand specific of the domain and specific of the questions.
Exactly. Yeah.
Yeah, so for me. I'm mostly doing data governance and data quality, and we have this saying in machine learning, shit in, shit out. Well, my colleagues always say gold in, gold out because it sounds better when it's about corporate stuff. How would you rate the data quality of the data sources, and how did you do your pre-processing?
What do you mean by data quality?
Data quality in the documents. So the structure of the documents, is the text consistent? Are there some missing words or something like that?
Oh, I got you. Mostly it is okay. It is totally okay, but like PDFs, it have its own nuances and its own problems. Like in whole PDFs, they're very tricky, especially tables very tricky to parse, to get this table structure, to preserve it in regular plain text, which you only can send to LLM. This was tricky, and some PDFs had a really big problem with it was something like fonts, broken fonts, or something like else. I really investigate that problem, and in 1 or 2 cases from these old 100 PDFs, it was something like Caesar cipher in all parse text. It was just garbled text with a little text with number, and this number was position offset on a side table, and you could like decipher this text, but I just can't comprehend why, who, what, why it was, and I just OCR'd these PDFs. There was a problem there. Yeah, there were.
I think these were encrypted PDFs that are in read-only mode, like Adobe has this capability.
I opened these PDFs not in Adobe Reader, but in like just Google Chrome browser. And if you try to just select and copy paste this text, it was still same mess. But it looks totally valid. It have only text layer. It have no like text picture, and you just copy and paste it, and it's not text at all.
So when I was preparing the dataset, so the idea was that we grabbed, I think a year ago, a large chunk of the internet in search of the public annual reports of the companies. And these were really diverse PDF files from different companies, including American companies, which are the usual listings, European companies, which are very diverse, and pretty much anything that was discoverable. And then during the actual enterprise RAG challenge run, we took a random subset. So it was unpredictable. It had to be a pretty much realistic representation of the internet, and it had this fun outlier that many people have stumbled on, that one of the reports had more than 1,000 pages. And a lot of people in the Discord channel were saying, hey, we started processing, and then I just went out and then came back to discover that my process was broken. But then I discovered that it wasn't broken. It was just slowly processing 1,000 pages, and it was just stuck.
By the way, I had no problem with this document at all. Also, I just didn't notice it. I noticed that, oh, wow, 1,000 pages just like later when I look through data.
And actually, while reading your submission, I saw that you were using Dockling library, which actually turns out to be a project from IBM itself. And like, why did you use it, and how did you discover it?
I discovered it. It's like a very sad story. I just tried some PDF parser, and I look at the results, and I look at the table parsed, and I think, oh, that is not a structure. And I tried another one, and another one, and another one. And later, I think a little dozen of different PDF libraries, APIs, proprietary services like unstructured, for example. All of them somehow messed parsing up. And the docklink for my tests with PDF reports return the best results. It amazingly good with parsing tables and with tables with merged cells and etc. It somehow can parse tables with merged cells in markdown tables that have not these options. It just repeat this merged cell several times, and LLM just understands this perfectly. So docklink was just the best out of 15 or 20 different parsers, and I tried all the best ones.
So it is a repeating pattern that you tried something multiple times until you find something that works. And while reviewing results of your submissions, so I noticed that you had actually 11 different experiments submitted with different combinations of routers, different combinations of libraries, different combinations of LLMs. So how were you able to be so productive? How you were able to have so many distinct architectures working for you?
I chosen the modular approach, and I make my system that way. So I had a configuration. I just pre-made all these configurations, and when I run the system, I just choose whatever I want, and in the configuration, I can choose the provider, the model name, the tricks and methods that I want to use, and I just try to make it highly modular. And all these models, not all these models, because I tested them more. When I tested some models, either it was good or not good, and I just included if it was good model, I just included it in my config, and then I tried out like different combinations. And about productiveness, I think after RAC challenge round 1, it become something like obsession. I want to research and to study, and for me this whole RAC competition, it is basically chance to study new methods, to study how to make a good RAC system, and all these tests and all these pitfalls I have participated in. This all just like for study, for get new information, for get new experience, and it helped me a lot.
Amazing, thank you. And because you had so many experiments published, and like we're including that in the information that we're sharing about the RAC challenge, a lot of people are now starting to understand what it was, what actually does it take to build a system that works really well. And I've been doing like an explanation, because companies would come to me and ask, "Hey, Renat, what is so special about the first place? Like, how was Ilia able to build a system that's so good?" And my usual answer was like, he won before even the competition started. Because before the competition started, he just took an effort to go for the documents, to analyze them, and just to run different set of configurations and find the best. And then as soon as the competition started, he just, and correct me if I'm wrong, he just took the configuration that he thought that would be the best. He ran it through the questions, and then he published the answers. And actually, the fun fact is that your winning submission took the score of 121, but actually your best submission wasn't this one. It was slightly different architecture, and it had the score of 126, and which is
and
actually
it was the first one.
I think so, yes. It was also the fastest one, under an hour. And the theoretical maximum that we had on this scoring system is 133. So it was very, very close to the theoretical maximum. And speaking of the theoretical maximums, and I want to go back into the uncomfortable places. Because like when we ran the first round of the Enterprise Rack Challenge, we had a simple question generator, and the first place was taken by a colleague of mine at TimeTag, who just used the structured outputs and chain of thought. And he pretty much brute forced the answering system. So for the second round, we said, okay, we want to explore the limits of this approach, and we took effort to make the question generator more difficult to predict. So the questions that would be more diverse and harder to pre-process for. And Ilia was also helping a lot by doing the initial analysis there. And everything was done in public. And in this round, we discovered that the non-vector-based approaches, they're also still good. I think the second place or the third place was taken by the non-vector approach. But the top place, it's the dense retrieval with carefully tuned steps, logical blocks in the pipeline. But one thing that we haven't explored that much, and we probably would have not explored it that much if it weren't for the IBM, was about the local models. And unfortunately, there weren't that many local model submissions. And I think it's actually a very important topic because like there's a lot of companies want to use AI, and they want to be able to send their data to get productivity improvements, but they cannot do that because it means sometimes sending private data to the cloud models and without controls. Like even you can try to get a zero data retention from OpenAI, but this still creates a lot of problems in governance. And that's why, first of all, I'm really grateful to IBM because you provided us with an API, which we shared with the participants that wanted to participate in IBM watsonx. And to that, I have two separate questions for both of you. So the first question to Ilia. So as I understand, you made your system capable of switching to different model providers. And one of the providers was actually the IBM, our proxy API to access the watsonx. So how did it compare? Like what were the good and bad things of using this way to use local models from the IBM?
Mm-hmm. I can make an important note on usage limits because before I found out that we can use local models with IBM API, I made a research to choose a provider that can provide API with open source LLMs, and almost all of them had very big problems with limit rates. Maybe I spoiled with OpenAI API that can give you like thousands of requests per minute, millions of token per minute, and if you want the same, I don't know, in like Anthropic Cloudy, you open their limits and you understand that even their max tier is just much worse. And when you are looking for open source LLM providers, the picture is even worse. And when I used watsonx API, I don't know what is the actual rate limits, but it was good. It was very good. Like for my impression, the whole 100 question took around 7 minutes on Llama 7CB, I believe. I sent it with batches on 10 questions in each. Yeah, and it was very good.
And were there any things that you missed with this kind of API?
you know my answer. The structured output, was the main pain. I made like methods that help me to use structured outputs, but it was like a roundabout way. And the structured output is really important thing right now. Maybe it is subjective, but I think it is like industry standard by now. I can't imagine my usage of LLMs without SO. And in my work, I use structured outputs, I believe, maybe 10 times out of 10. And I really missed that thing.
Could you, there'll be different people with different backgrounds listening to us. So could you elaborate like what structured outputs are? Because this is not the topic that actually you hear a lot when reading about the AI and RAG. And why are they so important for you?
Yeah, people who use like in UI, ChatGPT, they just never meet the structured outputs, but in developing it is a very important thing because you can get answers from LLMs in structured way, obviously, in JSON usually, and you can take final answer from response without regex parsing and similar head pain. It make it very easy, especially the one pattern chain of thoughts structured outputs. It helps to enhance performance of LLM to get them think aloud a little before they answer the question. And if you make it without structured output, you need to tell LLM to think aloud, and after that to put its answer, in triple backticks and then parse the answer. And sometimes it don't work, especially with small models like Llama 8B, billion parameters. And this saves a lot of times and a lot of nerves when you're developing something. Especially the one more thing that structured outputs helps with answer format. You not only can just extract your answer from JSON field with one line of code, but you can be sure that if you asked it to be number, it will be number. LLM physically cannot put in that field anything but a number. And with strings, lists of strings, and etc., it always will be the structures that you asked.
And there's a fun story. So we're working on a project to do the document extractions for the purchase orders from the PDFs and images. And I believe competitors were using highly sophisticated AI custom trained models. And we said that we're going to do it with adequate quality using just prompts in visual language model. Plain prompts, I think 1 or 2 prompts would be enough. And while we were able to do that, and we had to extract from a document, I think at least like 10 fields, at most it is maybe 20 positions in the large PDF, and we're extracting them pretty much in one go. Why was it possible? Because under the hood, the team was using structured outputs with carefully designed layout. So it was like a checklist that was forcing the large language model to think on the high level before narrowing down. And because with structured outputs, you can control exactly what model will be writing next, because you also control the order. So you can optimize its layout in such a way that the important fact will be in the hot part of the attention right before the model writes the next topic. So it just like, this is like you're creating a program that will be sent to the inference engine on the LLM. And the model within a single prompt while doing the response, it will follow this program and execute that. And when we're talking about the custom chain of thought, this is not just a simple list of strings saying think step by step before providing an answer. No, it can be completely very specialized. Like, first of all, look at the top of the page, figure out what is the unit of that is expressed in this table. Is it 1,000? Is it billions? Is it millions? Now look at the cell that contains the revenue number. What is the number? Normalize that, and only then provide an answer that is now no longer a string, an integer. And that's just a simple an example of short chain of thought that forces the large language model to look at a couple of places before arriving to a conclusion. And in the final answer, you'll probably need only the last number, which is an integral number that was created by accounting for a couple of gotchas. But you made sure that the large language model will go for these gotchas. And within a single LLM request and response, one can pack tens and tens of these tiny thinking threads, embed them into prompt once, and then make sure that the large language model will always follow that. And this is a recurrent pattern that we're seeing in the business. So now the question is, people that were participating with the IBM track, they said like, hey, does this API support structured outputs with constraint decoding? Because we're so used to that. And at that point, we didn't have this. But Daniel, do you think that maybe sometime later it will be possible to use IBM models with this capability?
I'm not allowed to say anything about the roadmap and this kind of discussion, but what I can say is that we're working with our development and with our users, and that's why we love this kind of challenges, to provide feedback to our development team, to our lab teams, to help them make their product more usable and more much easier to use.
Nice. And I think it was yesterday or the day before on LinkedIn, I saw news that IBM is starting to partner with NVIDIA. So you're rolling out NVIDIA NIM already in the ecosystem so that customers can use this to query the models. And NVIDIA NIM is just a packaging on top of a couple of systems, which includes TensorRT and VLLM. And VLLM natively supports grammar-based constraint decoding. So probably there'll be at least one more way to use this essential for the business capability in case.
Yeah, as IBM, we are doing a lot with our partners. We're also part of the AI Alliance with Meta. That's why we are also hosting the Llama models. And as IBM, we want to provide infrastructure. This is our main topic. That's why we also bought Red Hat. So we have OpenShift as base infrastructure. Then on top of that, OpenShift AI, then RHEL AI, and then watsonx AI. So that for every kind of persona, we have a kind of interface that they can use large language models with. And in this fast-moving pace that we have right now, with each month there's a new model, I think it's more important to focus on hosting different kind of architectures than to think about having the best model there is, because it depends on the use case. That's what we are seeing in our proof of concepts and our production use cases, that most often we start with the huge models in the beginning to kind of give a feeling about what large language models can do. But as we progress more and more into the production phase, we want to use smaller models, because in production you also have the inference costs that you have to think about. You have the return on investment, and the smaller the model, the easier the hosting is and the cheaper the hosting is.
And I think it can also provide a bit more. Also, it's a challenge to use smaller and local models, but it also solves a lot of risk problems with data governance, with security control. And I believe when I was talking to Ilia after the enterprise round 2, so we discussed that there weren't that many local models, actually, fully local-based solutions that were participating in the competition. And Ilia, do I remember correctly that you mentioned that for the next round you'd be interested in trying local embeddings and building, submitting a fully local model?
Yep.
And Daniel, basically now that we're talking about the local models, so on our personal benchmarks, which were the second generation benchmark which uses reasoning, actually it was funny that like on the top, they are dominated obviously by OpenAI, the latest reasoning models. But I think currently the 4th or the 6th place is taken by the DeepSeek, the R1 reasoning model, but also by the Llama 70B R1 DeepSeek Distill, which is pretty much a classical 70 billion parameter Llama model that was taught to reason if it's given opportunity. And if you actually supply it with a chain of thought routine that is enforced by the structured outputs, so the model was trained to reason, it can reason, and it produces answers that actually put it above, for example, OpenAI 4.0, which is sounds amazing for the customers that want to use high capabilities within the security parameters. So is this something? So this is something that shows up on our research, and this is something that shows up within the use of the small teams or within our AI research community, where people are trying to do new things. But Daniel, from your perspective, how does it look for the bigger companies? So are they already following this direction and using local reasoning models, or are they just getting started?
Yeah, from an enterprise perspective, there are different topics you have to think about when using AI. So if you have like secret knowledge, R&D knowledge you don't want to talk about, you don't even want to have the metadata in the internet, you need an air-gapped installation, because we want to use these large language models for our researchers to have a kind of rubber duck or something like that, to use these new technologies, but we want to have them on-prem. And that's why we are building our infrastructure such that we can also use it as an on-prem instance. And we're seeing that depending on the use case, the smaller models or the local models are used. So in some instances, we have really small models just for categorizing unstructured data and doing the classic NLU, NLP tasks. On the other hand, we're also seeing that these agentic AI systems also work with smaller models if you put a little more effort into it. It's a bit more work, but in the end, it pays out if you have the use case for it. And I think also with the EU AI Act and with regulations and also with risk and compliance issues, the drive to using local models and on-prem installations becomes bigger.
But essentially, so yes, local models are without any question of doubt are quite useful on the premises. But now if we're talking that the 70B model, which is not the largest model, it is medium size, and you can probably run it by using one or two H100 GPUs, which are quite available for the enterprises. And it provides a quality that is quite good enough. It beats OpenAI 4.0. It can compete with the lower level reasoning models, and it can run completely in air-gapped scenario on the premises. So basically, doesn't this completely solve all the problems with data governance and compliance, or is there something else?
It won't solve data governance and compliance for one thing, because still, in order to have a transparent system, you need to know which data was fed into the model, exactly which data. So the EU AI Act states that if you have a high-risk use case, the provider of the model needs to give out the data that was put into the model. And this is something Llama cannot provide as of right now, and also DeepSeek cannot provide, which is why we as IBM have our own line of models, which are smaller, but where we vetted the data that went into the training. So it still doesn't solve all the issues, but it goes in the correct direction. And this is something we're seeing in the last few months, in the last not last few years, like in the last year, we've seen that smaller models become more and more potent, and the drive goes into the direction of open source models. And I think this trend will continue.
Nice. So basically, currently the outcome is if you're a company or a business and you're building something that can be hosted in the cloud, so the best results can be achieved by using the best cloud offerings. And if you're a business that is privacy sensitive, you can still achieve the best results, first of all, by building something on the most powerful models, using only a subset of anonymized data, as Daniel said, because you want first to prove that it is technically feasible. And then if it's technically feasible and it can solve the problem, then you can actually invest effort in making it run within the air-gapped secure setup like IBM watsonx or any your own on-the-premises provider or somewhere else that provides maybe even confidential compute. By the way, does IBM provide confidential compute?
Yeah, we have in our cloud HGPs, we're seeing that we're not using any customer data. And when we're on an on-prem solution, it's air-gapped. So in each direction, we don't want to use customer data, because we are saying we want to be a solid, trusted technology provider. We don't want to use any customer data, because that's your part. In our cloud, we even have the concept of keep your own key, not only bring your own key. So we don't have any access to cloud infrastructure when a customer bought it.
Nice. Okay, so long story short, we're talking about the Enterprise Rapid Challenge round 2, where we had multiple teams competing. We had more than 300 initial 50 registrations. And in the end, we had more than 100 of submissions that were submitted by different teams, trying different architectures and approaches. And each submission came with their insights, which were provided by filling up our AI survey. And the best solution that was topping the leaderboard was based on Ilia's risk approach, where he invested a lot of time to create a modifiable, modular architecture upfront. And then he used evaluation data to simply, I would call it brute force because it's partially brute force, the right conclusion, but it required a lot of other smart decisions and trade-offs in making the right choices at the right moments. But he was able to take his pipeline and optimize it, find the correct tuning points and finding the correct parameters. Because under the hood, it's still the RAG system, which is retrieval augmented generation. Except there were so many correct decisions that were made at different places. What is the embedding model? What is the retrieval approach? What is the strategy for figuring out handling different questions and answers? And that this ultimately led to architecture that was submitted to the production round of the challenge, and that got the highest scores. And because we're trying to run essentially crowdsourced AI research that helps to push the state-of-the-art worldwide, so Ilia is helping us to do that by sharing his approach. And hopefully for the third round of the Enterprise RAG Challenge, we'll prepare in advance the same evaluation framework that Ilia has made. So sorry, Ilia, you're going to probably lose your advantage, but we're going to make it available to all the participants. So anybody will be able to try to brute force the approach using different technologies, and they already have the evaluation data set. And this should also give some challenge to all the participants. We'll try to focus more on the local models because they weren't provided enough in the competition, and the businesses are really interested in the air gap solutions. And hopefully we'll get something fun done with IBM and watsonx. And so, long story short, we made some discoveries. We found some new insights. And later, maybe this year, we're going to run the third round, where we'll make things more difficult for the winners and more interesting for the participants. How does it sound?
Sounds great. So congratulations, Ilia. Thank you, Rinat and TimeTech very much for hosting this event. It was a lot of fun working with you.
Okay, thank you. And let's hope, if we're calling this TimeTech and IBM episodes, so this will be the first episode, and we'll record the second episode sometime later. Thanks.
Thank you, guys.
Thank you.